When we talk about weather, we usually reduce it to a single thing: one map, one model, one outcome. But the atmosphere doesn't work that way. Weather is a system made up of layers that interact, evolve, and respond to each other in real time. Radar shows us where precipitation is falling. Satellite shows us the structure above it. Lightning reveals where energy is being released. Models add context to the situation. Observations ground everything in reality. None of these tell the full story on their own, but when you connect them, the weather starts to explain itself. Hey, everybody, welcome to the Weather Breakdown. If you're new here to the channel, this channel is all about taking weather seriously, not as headlines, not as hype, but as a system that can be admired and understood. We're not jumping ahead here, we're not doing any forecasting, and we're not trying to paint a storyline into the future here. Instead, we'll take a closer look at how the atmosphere behaves today and how it produces the weather we can experience at different scales and with different signals, and combine those signals together to paint a broader picture of the atmosphere. We'll start by going broad and progressively going deeper, deeper, and deeper, and letting the atmosphere speak for itself. So let's dive straight into our observations and see what we can see. So we've now arrived here at our observation platform here. We can see a closed circulation in that direction with a frontal boundary oriented like that. What we can also see is a tight spacing of the 500 millibar height line here, meaning that there's a jet maximum moving in that direction. What you can also see is downstream of this jet maximum here, you can see the flow here starts to diverge in the southern branch and the northern branch. This flow here, you can see also as it gets deflected in that direction, there's a jet maximum here as well, circling around this upper level low, where it branches off in two directions as well. Where it branches off in this direction, you can see a jet maximum here as well, being the driver of this upper level low, while this cyclonical circulation leads to an upper level low there as well. As this flow starts to diverge, you can see that it sets up this whole anticyclonical circulation here, circling back towards that way, leading to high pressure area in that location. So when we look at it a little bit deeper, what you can see here is a nice meteorological feature. Okay, we see here a deformation zone where you have airflow moving in that direction and starts to branch off. You have airflow moving here in that direction and starts to branch off in that direction. You have here airflow moving like that, and here airflow moving like that. Okay, where the air starts to move towards each other is called the axis of contraction, and where the air starts to move away from the collision point, this is what's called the axis of dilatation. Dilatation, contraction. And we can observe a number of things here, because when this airflow moves like this and this airflow moves like that, eventually there's a region where the two will meet. Okay, and where they meet, you can have some interesting stuff going on. And to see what's going on here under the hood, we need to turn on the water vapor imagery, because that is a good indicator to show what is actually happening. We already mentioned here this cloud band here. Again, let's draw the same thing. We have our upper level low system here, and we have this nice defined cloud band here. Now, what you can also see here, next to this cloud band, you can see this region here where the colors are darker. You can see the same thing here. Colors are darker here than they are here. Now we can already derive some very useful information from that. Because if you look at water vapor imagery, air that starts to sink appears darker on water vapor imagery, meaning that as this airflow moves like this, it starts to sink towards the ground. As air moves like this here, it also starts to sink towards the ground. So we have two sinking air masses. What will happen with the one in the middle? You think? Yeah, you probably guessed it. It starts to rise because of the two sinking motions. It's put it upward, leading to condensation, leading to redistributing the moisture that's closer to the ground, putting it upwards into the atmosphere. And that's why you see this pronounced water vapor signal here as a cloud band. Now you also know this here is upper level motion, this here is sinking motion. We'll delve into it a little bit later. But everything that's either white or blue or light gray, you can interpret it as upward motion. Everything that's dark gray, yellow to black is sinking motion towards the ground. So this is a very good indicator. If you know how to use it correctly, you know how to interpret water vapor in terms of sinking and rising motions in the atmosphere. Now we can expand this knowledge a little bit further as well. If we pan the map a little bit, we've already identified here that there was this anticyclonical circulation here moving in that direction. And you can see it coming here. Okay. What you can also see is you see the same. You see here this airflow diverging like this and this airflow diverging like that. You can also see a very nice delineation here, and this is also called a deformation zone. And you can interpret this in the following manner. If you look at the brightness temperatures here, the brightness temperatures, they go from blue and light gray, and if you look at the flow here, you can see that it gets darker, which means that as this airflow curves around this high pressure area and in between this upper level low here, you can see that the branch here, as it starts to branch off, it sinks. If you follow now the logical thinking behind it, you have higher brightness temperatures here, lower brightness temperatures here, and you have warmer and darker brightness temperatures as it starts to move here, meaning that as this air curves around here, it starts to sink. You have the same situation here. Air moves around this circulation and it reaches here, starts to sink, and becomes more or less the dry intrusion of this system. Now you can see that everything is connected. You cannot see anything in isolation. You need to see everything combined together. And this is also the reason why this product is here, to layer all these features on top of each other to show you how the atmosphere actually works. Now, if you now turn on the radar here, you can see a number of things as well. As we already identified, there's a cyclonical circulation moving in that direction. If you zoom a little bit in on the 500 millibar height lines here, you can see the following. The 500 millibar height lines, they start to diverge here. They're closer spaced together here than they are there. This leads to upper level motion, leading to the precipitation signals, as you can see there as well. If you zoom a little bit in even more, you can see that this upper level divergence, the air diverging away in the upper levels of the atmosphere, is aided by this here. If we draw these vectors here of the wind closer to the ground, you can see that they are moving in that direction. Here, they're moving in that direction, here in that direction, and here in that direction. Here, this whole region here, if you look at the streamlines here, they all start to converge there. So you have air disappearing at the top of the layer. You have air converging at the bottom of the layer. This sets up this whole vertical motion, and it redistributes the moisture of the Mediterranean. It pulls it upward, leading to precipitation, as you can see here. But if we zoom out, it also contributes, as we've already mentioned here, to the colder brightness temperatures in the water vapor imagery, as you can see here. Again, it's all connected. You cannot see a specific thing in isolation. You need to correlate everything what you see to paint the right mental picture in your head. Now, what I've done in the video, guys, is take the time to explain meteorology as it is. We were using concepts like deformation zones, water vapor imagery, and model data combined together to explain how the weather over the Mediterranean behaves as it does, leading to the precipitation currently affecting the southern portion of France. And that kind of information can only come from combining little bits of pieces together and from using tools that are built to show you how these different pieces interact with each other, not just to display them in a separate manner. All the products, as you see here, are custom built with exactly that reasoning in mind. Combine all these things to make it possible to connect the dots, providing you with the bigger picture. And that's very much the mental philosophy behind this channel as well, so that you can not only see that there is precipitation, but to provide you with the understanding of why and the concepts behind it, so you yourself as a weather enthusiast can paint that full picture in your mind. Thanks for watching, everybody, and see you in the next video. Bye, guys.